Thank you very much. I'm absolutely delighted to be back here in Linköping, and in order just to show that, This works?
Yes.
Now I have to show the picture of when I first made the acquaintance of Nahid, and we were, of course, in the ice barns in Stockholm, and it was such fun. We also, on another occasion, visited Nilesgarten, and that was a great sunny day, and I put this picture up. It's one of my favorites to illustrate that this talk is also about vision and what the future will be. And I'm very happy also to be the last speaker, because it means that I can refer to everybody else's talk. And in particular, I was very amused to see the picture of the Google clusters coming up twice, but since I'm so keen on cooking and food, I decided to put up my own one. which is Parmesan cheese, and I like that one. Right. So, of course, this is part of the cloud, and before I start on the real theme, I wanted to give you a sense of the kinds of figures, as with the other big companies we've been hearing about, that we have to deal with these days. So this is not all that Microsoft does. Microsoft has many, many arms, Windows, Office, all of those things. But these are just some of the figures regarding email. So, and the pictures that are stored on our servers. So we have, this was a while back, 375 million users, 6.75 trillion photographs are stored up on these servers. And, of course, so many queries, and people expect that the results come back very quickly. Now, that's one of the things that happens in the cloud. And, of course, we know actually how to deal with this kind of software. We've been doing it for a good while. But the world is changing. I want to just talk a little bit about that while I show you, without any sound, this video. So the world is changing insofar as we now have devices and we have applications. And these things are so different to what we've had before because they're tangible. And you can see in some of these pictures that are coming up, people are touching things. The word is that you touch things. And that makes it much more difficult and more complex to actually write the code that is going to enable this to happen. All of these pictures, as you can see, are done in Microsoft Research. Microsoft Research is a tiny portion of Microsoft. Microsoft itself is over 100,000 employees worldwide. Microsoft Research is only 1,000. So we have 1,000 PhD researchers spread out over 9 laboratories in the world, and the majority of them are in Redmond, where I am. In addition to the researchers, we grow by about another 800 in the summer when we have the research interns coming into the research labs. They're mostly leaving at this point in time. And we need those interns, so some of you should think about applying, in order to fill in for these new ideas to solve these new problems that we have. And what I'm going to talk to you about are 4 of the projects that I've actually been involved in over the past 4 years since I've been in Microsoft Research, working with the researchers in order to get their research out into universities in a really accessible way. It occurred to me when I was asked to give this talk, and this is new, that things have changed. So we used to have hardware and software. Now I define it, and these are my definitions, and we can sit and argue about them, but Hardware are desktop, laptop, servers, big things. Software is also big things, large, installable, cross-hardware systems. Things like Office. Office is a suite of programs. Right. Now, devices I would refer to as small things, things you can hold in your hand without sort of picking it up. So these would be tablets, phones, consoles, gadgets, sensors, GPS systems, the wonderful things we saw in the last talk, all of that. They have their own ways of being programmed, which turn out to be somewhat different to the previous lot. And then the services which we need to access these are also different, and the names that we come across here are apps, browser-based systems, APIs, and web and cloud-based services. Now, there is some terminology sort of conflict here. People like to these days say apps are programs. Well, I think not. I think programs are still programs. Programs are the big things that go through software engineering practices, cycles, and get produced and issued and announced and so on. Apps tend to be a lot more fluid, and anybody these days can write them and put them up in an app store. So that kind of programming is somewhat different. I'm going to show you how we adapt to that. One slide on history. I did some research on this. IBM, one of the companies there that we've mentioned earlier today already, was founded in 1911 as a hardware and software company. Microsoft, 1975, was a software company. They wrote software for IBM's PCs, effectively. Apple, 76, just a bit later, was a hardware company. Now, you'll say, no, they wrote software. Yes, they did write software, beautiful software, but it was software only for the Apple. So I'm therefore putting it in there. They changed that policy later on with things like iTunes, which then was distributed and usable elsewhere. But at the time when Apple started, the software was for the Apple. And Google, of course, started out as a search engine company, so it was initially a services company. And that all changed. If we look at 2013 now, we've got everybody almost doing devices, in other words, those little gadgets, and making them and selling them, and doing services. Probably IBM is the only one who's not bringing out devices at the moment. So everybody's in this game, and everybody's wrestling with how to program these things. Just to look at some figures, here are some projections from a reliable source. In 2013, where we are now, the red bars there are the smartphones and tablets. And as you can see, the projection is pretty high. It's going up, 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 up. The blue ones are the what we call the hardware, and those ones are not. They're increasing, but not at the same rate. So the increase is really in the devices side. Now, in the API side, something even more surprising happened and is happening, and that is that everybody these days, and look at all those logos there, I'm sure you recognize many of them, are making open APIs for people to use. I think eBay was the very first one of the major companies to do this. And now everybody is putting out their APIs for people to use and access their systems. Here is something I just pulled off today of the top APIs, and I pulled it down as far as Ericsson, which is even on that list. So as you can see, the other ones, Amazon, the ones you would expect, Google, Twitter, and so on. So everybody's supplying APIs to access services. Now, the devices we buy are these things. And they're all over the place. Of course, there are the other side of devices that we saw in the previous talk as well. But how do we program these devices and how do we access them? We need browser-based systems to get across the different types of operating systems, as I'll explain. We need cloud services to store the data, and we need apps to run on these small machines. Just to mention, by the way, the reason why this one looks slightly different is that this was only announced today. It's the Microsoft's Surface 2s were announced, and this is the Surface 2 Pro with its pen-based system. Very nice machine. There's also a Surface 2. So that's not unusual. I mean, Apple announced another device just a couple of weeks ago, and I'm sure there will be more just before Christmas. More and more of these things come out. Software has to keep up. The devices for experimenting that we have also need special software. So here we have on the left-hand side a system called Gadgeteer, which is sold in Britain and I think over here as well, for making little experiments. And here we have an Arduino, which is changed from the Arduino, and it has lots of lights on it. And this particular experiment I saw 2 weeks ago at UCL, and what it was doing was showing how to do a disco with this little machine with the lights flashing, and some first-year students had set this up with their tunes on their computer. So let's look now at a system which I've been involved in for a couple of years and try and learn something from what how one approaches this. So the idea here with Touch Develop, which is the system, is that many people's first computer that they'll ever have will be a phone. So if your first computer is a phone, you can do lots of things with it. But the one thing that up until now you haven't been encouraged or able to do is to program it. Now that's a great shame, because it's a great computer. And if you needed to program it, you had to go to another computer, make the program, and transfer it over, which not very many people would actually try to do. Ordinary people, that is. So we invented this system where you could actually program on the phone, for the phone, in a very nice way. And we brought it out as a Windows Phone app. Okay, the only problem was not many people had Windows phones. So it didn't really penetrate the market, let's put it that way. Although it was a great project. So we rethought. And what we decided to do was to transform the system into a web app. And once we did that, it could be available on any system. So it is now. It's available on any of the devices you've got up there or in your pocket. You can go to touchdevelop.com. It doesn't download. You don't install it. It just runs in the browser. Okay? And there's the group of fantastic people that I worked with on this. It's become enormously popular. We have people using it all over the world. We've had 310,000 downloads of the app itself. We've got many, many registered users. The things that we make here are called scripts, and we've had only over 35,000 scripts made in what we call the bazaar. So the bazaar is like a store of shared scripts. Everything is shared, and this is a bit different to how one would normally program. So you write your little program, but it's not yours. It's everybody's. And anybody could fork off a new version. So it's like open source right out there in the wild. And then we've had actually 670 of these submitted to stores. And you can submit them for the normal process where they have to be verified that they're not going to hurt anybody else's computer and so on. Now, how does it actually look, Touch Develop? Well, it's a typed language. It's a proper language that has everything in it you want, right? So once you get in here, you're going to really be learning something. And it's a semi-structured editor. And that was the key, because the main driver was this phone, and you had a big finger. So you got a phone and a big finger, and you can't really tap each letter of a program. This is not going to work. So we had it with auto-completion of the statements that you were going to write. And I'm going to show this to you actually working. So let's do that right now. Okay. Here's Touch Develop running. So this is what the open link screen looks like. As you can see, it's terribly colorful, appeals to, whoops. I think I've got to do something, don't I? I must first of all mirror. I've got to mirror something. Who's an expert on I've got to go to, who's an expert on how to get mirroring going?
Windows button and P.
Windows?
And the letter P.
P. Oh, great. Let's try that. Oh, there. Thank you very much. I knew there was a short way. Thank you. Yeah. Okay. Very colorful. Okay. So here we have our showcase. And why I thought this was great was we heard Lisp mentioned earlier. And somebody had written a little script for Lisp. And this was one of our high school interns who wrote this. So here it is, Lisp for Touch Develop. We can run it. And there it is. It's a little REPL type system for running Lisp. And it's running on top of Touch Develop. So we could just run that little program there. But I haven't shown you Touch Develop. I just thought as a reference to the previous program, the previous talk, that was really quite cute. Now, let's go here. Let's look at what Touch Develop actually looks like. As you can see, it looks like any other language. It looks like Java. You're going to learn something if you go here. And if we go to a line like this, we can make changes. So I want to find one that would actually enable us to, right, let's, right. So when I click anywhere on any line, up pop a lot of tiles. And the tiles indicate to me what I can do next. So if I then pressed on there, it would tell me what I can do next. And I can make changes, and it will immediately tell me if I've made an error, and I'm not allowed to make errors. Right? And I can go to help, and everything is there. It tells me what is enabled. And this is all optimized also for the phone. So let's go back. So Touch Develop in the wild is really available, and it's there for you. But the main thing, of course, is that what we wanted to do was give access to everything that was on the phone, because it was such a powerful little computer, and there was all these sensors and data. And so these are now all enabled, all these things here, as first-class citizens through APIs and data objects in the language itself. And the architecture of the system is different. And I want to mention this because this talk is really about software development. It's different depending on whether you're in the phone version or in the other version. And the other version has to rely on a base level of HTML5. And just some comments on HTML5. Here is the number of lines of code that we had to write. It was not a small project. And it's continuing, it's getting bigger. There's lots more being added at the moment. And who's heard of TypeScript? A couple of you, great. So what TypeScript is it's a language coming out of Microsoft Research. It's open source, it's out there. You can go and change it. About 700 people have. And what it is it's JavaScript with types. So writing such a big system in JavaScript would not be possible, right? It would be a nightmare. So TypeScript has been developed by the same people who did C#, Anders Helschberg and so on, and they've got it in, it's going to be standardized by ECMA as well. So that's something to know about. You can actually run TypeScript also as a converter to JavaScript, and it's a very nice system to develop in. And why it's a nice system to develop in is that, in fact, HTML5 is really very, very horrible. It has no effective standard for storage, sensor access, data access, and lots of quirks. We have full-time people just making sure that our system works on all the different engines. And ta-da! Right, the cloud. What we've just announced recently is that we have cloud state. And this means that you can have two of these devices actively working on the same data in the cloud at the same time. This sounds trivial. It's not trivial with mobile devices, because at any time they can drop. And then what is the actual consistency model that you're going to use, and how does it work? So the old-fashioned way, sorry, not the old-fashioned, but the traditional way would be that you would just update from devices as you go. But with the cloud session model, you can't do that. You have to synchronize when you've got a connection. And this has now all been worked out. The papers have been written, and the system actually operates beautifully. You can play games. You can write a game like checkers or something like that and play it. And if one person goes out of range, it just waits. And then eventually everything syncs up again, and it uses causal consistency. So in summary, Touch Develop actually embraces the new reality. It's a model for all the new things that you would need for a system that is going to use devices, for software development and new devices. It's not finished. We're forging ahead and doing all sorts of things. If you want to come and join us as an intern, if any of you are still students, please write and suggest something. We'll love to have new people come in with new ideas. These are some of the open challenges. We need more plugins for cloud development. We've got a problem with the structured program code repository. We want better real-time group editing, which we don't have. Many people program in groups. At the moment, you can only have one device working on one program at a time. So clearly this is something we can fix, but it's not yet been fixed, and we have to work on that. And we've got a debugger going now, and we want to do direct editing of the TypeScript in the background. So there are lots and lots of things we can do, and lots we can do. Just to mention that one of the nice things about this system, because earlier Barbara also mentioned about manuals, is we took seriously the ideas you've got to have the manuals as you go along. And we've written a book. This is the third version of the book. It's available free. You can get it on Amazon, or you can get it off the website online. And otherwise, if you want to actually get the hardback version, you can pay for it. And we also have competitions, slides, books, and all that kind of thing. We also lend phones to universities if they want them. So that's all about the devices side of things. The other problem that occurred to me when I first got to Microsoft was that not all universities really liked Microsoft very much. And part of the reason was that they had what they called, professors said they had heterogeneous classes. So if there was a class like this, the students would have, some of them would have PCs, some of them would have Macs, others would have Linux computers. And so they would endeavor to use the lowest common denominator software, which, or you could call it the highest common denominator software, but basically something that would run on all of those, and they'd have to choose that. It was usually Java or something. So if we were to break into that with our really cool tools that we had to think of a different way around the corner. And that was these browser-based systems. So the idea here is that you use the browser essentially as your operating system. This is not a brand new idea, but we took it to extreme lengths. And then on top of that, you have your actual software you're going to have, and then people write on top of that again. So let's look at two examples. The first project I was involved in was really an industrial strength one. It was to take a functional programming language, F#, which is a big language which is shipped with .NET, with Windows, and it's used largely in the financial arena, in financial world, because it enables you to have what are called type providers. So you can go and you can collect off the internet types, data with a particular type. So you can see here Netflix, get data context, or financial data, get data context. A type provider is really just like a library, but it refers to the types. So it's abstract data types taken to the nth degree. And we have type providers already for all of these, and they're probably twice as many as these now. I haven't been keeping a watch. So all of these are places that define how types work. So this is on the interface of database research and programming language research. It's where they meet. And you can define these, put them out there, and then everybody can use them. But you can write them yourself, of course. And this is how it looks. So Tri-F# is a really fancy system. In the middle is where you can write your code. On the left is, as with Touch Develop, it's all the programs you've got and some tutorials, and on the right is your output. So this is showing volcanoes and earthquakes on recently through access to a type provider provided by the geostatistics data services. Okay, so I'll just, I won't show that to you, but we could go back to it. There have been several papers, very good ones, written on this. So it's called Internet Scale Information Resources. So we need to have data which is going to coming over the internet, and we should be able to handle that in our programs. And that requires a completely different way of programming for services. Actually, I think I will show it to you because it is jolly cool. Let's go to here. Here it is. Okay. So, as I said, this was really a industrial strength one. The next one I'm going to show you came much more from the researchers. This one, we polished it up. So if we were to learn about this thing, there we are. We could go and get started in F#, or we could do advanced F#. We can do scientific computing or financial computing. Suppose we went to financial computing. It would give us a tutorial here, and it would say, okay, well, let's go to financial modeling. Using financial modeling, how to access data, it would tell us, and then we could do a load and run. There we go. And it just says there's our program, and then we can run it. And we can get even more fancy programs there, and we can run them. So it's a sort of a REPL loop again, and because it's functional and immediate and dynamic, you can do edits and go around and everything. And this is all running inside this computer. So what's happened is that the whole compiler has been brought down into a sandbox in the browser. So it runs in every browser in a sandbox. And it's quite small, it's only a megabyte. And that is one way of doing this browser-based software. Now, that's not the only way, because in order to do that, you do need to have a particular type of sandbox software, and in this particular instance we used Silverlight. Now those of you who are aware of Microsoft's deprecation policies, as John said, you know, there are 3 ways of doing things and one's deprecated and 2 don't work. This Silverlight has been deprecated. So we can carry on with this, but we can't expand it, which is a bit of a shame. So let's look at the other way of doing things. We discovered that Microsoft Research had about 30 wonderful tools that they wanted to get out to researchers. And they were all over the place, and researchers had to download Windows and .NET. And so what we did instead was we put them up on this website called Rise for Fun, and you access them from Rise for Fun. They all have a similar look and feel now. They all use the same editor. They use IntelliSense. They can, and these ones do not use Silverlight. They run on a server back in Redmond. So these are, right, let's go to the, should have stayed there actually, but we can go there. Yeah, come on. Ah, right. Okay. Yeah, I'm stuck. All right. We can't get that. We will in a minute. Okay. So after Rise for Fun, we had this nice idea that what we needed to do was help students with their programming. And this particular system, which I mentioned in our in my abstract, is called Code Hunt. And it's similar to what I showed you with the Tri-F Sharp, but what's running in the background is a very sophisticated unit testing engine. And so you can actually come up, get a little program that you're meant to try and find the answers to, and it gives you the unit tests, and then you've got to fix it, run the unit tests, and go round and round and round and round. If I could get out of there, I think it's working now. Yay. Good. Just got stuck. All right, so now we can go there, and we can go here. Sorry, there. Okay, so we're going to go to that one as an example. But here we've got Rise for Fun. And as you can see, these are all the different programs that you can run. We then discovered that we could actually accept into the system tools from other places. They didn't actually have to be our own tools. So this has become a portal for other people to put their tools in as well. And it takes us about half a day to get the tool in to this system. So we've got some of those, and if you have a tool and you'd like to add it in, the reason for adding it in is twofold. One, you get the great editor, and secondly, you do get some publicity. So I wanted to show you PEX. PEX is here. So this is PEX. Now that doesn't look anything like the previous slide I showed you, because this was the old version. It's been used 1 million times and people love it. What happens is you do this, you then ask PEX, and it tells you that you need to have, you've got to fix the code. Right, there it is. It says it works for these values and it doesn't work for those. Right, so let's conclude. I think that the future actually is very, very, very much in that there's going to be a convergence of basic platforms. There's no way that we can have too many platforms. Even in Microsoft, there is now convergence with some of the different Windows platforms that are out there. Of course, they emerged because the hardware was different, but we're trying to converge them a bit more now, also to ensure that the experience for people is similar. There's a greater reliance on the cloud for all the good reasons that we've heard. In particular, for devices, you can't drain your battery. So one of the things we've got in Touch Develop, which I didn't mention, is that you can, the system itself, although this is experimental, can work out from static analysis whether a computation is going to take too long, and then it will send the computation to the cloud. You don't know that. And it will do the computation in the cloud and then continue executing on the device itself. Seamless access to big data through type providers is obviously very, very important. We would love it if people did the browser languages a little bit better, but of course what we're doing is moving ahead in that with TypeScript, and I'd love you to have a look at TypeScript. It really is a very nice language. You can just look it up through Bing and find TypeScript, and you get one of these nice windows to try it out. And there will be more and more, and Andy has mentioned this as well. I don't think we'll go to artificial animals, Andy, but there will be more and more gadgets and sensors. There's no doubt about it. That's where the world is going. People will just invent stuff that we can't stop it. And then they have to all be joined. Once you invent all this stuff, it's going to have to be joined together. So there will be an internet of things, which we already have, and labs of internets of things for people to do experiments on. Thank you.